In the experiment of determining the formula of an unknown hydrate, I have selected here several hydrates in which I'm not going to mention how many molecules of water they contain. So this one is iron chloride X hydrate. This is aluminum nitrate X hydrate. This is barium chloride X hydrate. This is calcium nitrate X hydrate. This is barium hydroxide X hydrate. This is sodium phosphate X hydrate. The one over here is ammonium ferrous sulfate X hydrate. The one over here is magnesium sulfate X hydrate. And the last one is copper sulfate X hydrate. So as you can see here, all those evaporating dish or crucible contain hydrates. What we're going to do, first of course you measure the mass of the evaporating dish or the mass of the crucible empty, and then you add to it a certain mass of the unknown hydrate, and then you subtract their masses to see how much is the mass of the hydrate. Of course, the hydrate contains water. And now the next step, each one of those, you are going to heat it on a Bunsen burner, over the Bunsen burner, until all the molecules of water evaporates. So as you can see here, the first hydrate, we are heating it, and you can see clearly that the texture is changing because the molecules of water are evaporating in this hydrate. We have to keep heating it until all the water evaporates. So now again, after a while, you can see that I still have few molecules of water, but the rest of the iron chloride hydrate, the rest of it evaporated already. Over here I have the aluminum nitrate. I just started on heating it, so we're gonna wait a while and see how the crystals will change once they lose their molecules of water. Once you start seeing kind of yellow fumes, you can know that most of the water molecules evaporated. So over here I stopped heating it, and now I'll wait a little bit until the evaporating dish cools down, and then I will measure the mass again. Of course, I need to minus it from the mass of the empty evaporating dish, and like this I will now have the mass of the anhydrous iron chloride. So here again, this is taking some time, the aluminum nitrate. Now I'm gonna show you other hydrates that I am heating. So over here I have the barium chloride X hydrate. I'm heating it, and over here I have the calcium nitrate X hydrate. This is very fast. You can see very well the water started to evaporate from the hydrate. We just have to wait some time until all the molecules evaporate in order to do the mass, in order to measure the mass again. I now started to heat the barium hydroxide hydrate. Now I'm gonna show you the second one, the aluminum nitrate. You can see that the crystals started to lose their water. This one also, I can see this is calcium chloride. I can see that I have the crystals turning more into powder because they started to lose their water molecules. This one is very fast. This is the calcium nitrate X hydrate. So you can see here that many molecules of water started to evaporate. Now the color, the texture of the hydrate definitely is different from the texture of the anhydrous. Okay, so the hydrate is more like crystals, the anhydrous is more like a powder. So the barium hydroxide hydrate almost done, so I'm gonna turn off. You can see clearly that the hydrate turned completely into anhydrous. So I'm gonna turn off this one. The aluminum nitrate still, it's taking more time. The barium chloride almost finishing. For this one, the calcium nitrate, I think I still have some water molecules. I'm just gonna show you something here, nice. If I just add a few drops of water to the anhydrous, it's gonna go back again to be in the hydrated form. So it's a reversible, kind of reversible reaction, because the hydrate only has to lose the water molecule in order to change to anhydrous, and the anhydrous, it just have to add water molecules to it to give back the hydrate. So that's it basically. These are the steps of the hydrate chemical experiment. So you just have to take the hydrate, heat it up, remove the water molecules from it, measure the mass before and after, and the difference would be the mass of the water that evaporated. And then you will do your calculations in order to determine the formula of the unknown hydrate.